What we're going to do here is look at a simple example of integrating and using Firebase cloud messaging with an Android application. So this is a basic app with a views activity. I have no special declarations or permissions in my manifest. And I'm going to start by integrating FCM into my application by using the Firebase tool built into Android Studio. So I'll start by simply going to Tools, selecting Firebase, which will pop up a tab. And then from the list of available Firebase services that I can integrate into my application, I'm going to select Cloud Messaging. And then I'm going to select Set up Firebase Cloud Messaging, the first option, since this will be a Kotlin app. The second, as noted here, would be for Java. And this will give me a guide with some text instructions. Now, the guide is basically broken up into a few different pieces, a few different parts. The first is I'm going to be asked to connect my application to a Firebase project. This will essentially just download some files to my project, allowing me to connect to and utilize certain Firebase/Google services so that my usage can be monitored and charged if necessary, all of that good stuff. So I'll start by hitting connect to Firebase. And this will bring me to a login screen if I hadn't already logged in. And then I'll have the ability to select an application. So, I select a project. So I'll select a project that I had previously created. You also have the ability to create a brand new project. And then from here, we will just have some authentication between Android Studio and Firebase. Once I hit connect, the two systems will be connected. And now if I switch back to Android Studio, I'll see that I have a little checkbox here telling me that my project is connected. Check mark. Next, I'm being asked to add FCM specifically to my application. So now this is going to download and add the libraries and set up the necessary dependencies so that I have Firebase Cloud Messaging available. So I'll hit add FCM to your app. It asks me to accept the changes. I'll go ahead and do that. And this takes a moment. Again, I just need to watch the progress bar at the bottom of the screen. And once this is done, I will officially have Firebase integrated into my project as a library. So it's available to me. Now I just have to use it. So using it is what the remaining steps are for. And there are different use cases, different features that you would need to implement differently, all depending on how you intend to use Firebase. As it stands, without doing anything else, my application actually now has the ability to receive FCM messages. However, I can only receive messages that are non-targeted, meaning they're going to be sent from the Firebase console, which is a tool that Google provides that allows you to run campaigns and do analytics to increase engagement in your application. So basically, you can send an FCM message that shows up as a notification. The user clicks the notification and it opens the app, goes to a specific place, passes certain information in. So again, I have that feature available now, although unless I build in the necessary pieces to make it useful, you're not going to really get much from it. So we're not really done in the strictest sense. If I want to use FCM in a more targeted way, that is, I want this specific instance of the application running on a specific device to be the only one that receives a message, or have this instance of the application subscribe to a specific topic so that a message sent to that specific topic will be received by my application. or any of the other more involved use cases, then we have a little more work to do. So the first thing I need to do is I need to get my device's registration token. A registration token is made available to every instance of an app running on a device, or every instance of your app running on a different device will receive a unique token that needs to be fetched. It will be provided to you from Google servers, but once it's arrived, you then need to send that token to your application server. In other words, for an app server to send a message to your running instance of the app, it needs to know the identifier that was provided by Google. So you generally have to have some sort of flow that you have to build into your application for that to work. Whether it's your application server provides an API or something must be available for you to send the token, send the key to the server so that it can communicate with you. So in order to do that, in order to fetch the token, what we're going to do is we're going to create, per the instructions here, we're going to create a new service. Now, I should have pointed this out earlier. It may not come as a surprise to anyone who's been working on Android for a while. As of this recording, the instructions here are wrong. And that might, that's a bit peculiar to a lot of people, especially to me, since the changes that were introduced that made this documentation outdated happened literally years ago. But somehow Google has not gotten around to changing the documentation as yet. So the problem here is that the documentation refers to, for steps 3 and 4, utilizing 2 different services as the base class for your implementation of 2 separate classes that will allow you to get your registration token, and then, which is what we're going to do next. And then secondly, to handle messages that are sent to your application instance, whether directly via your token or generally via a topic subscription or a message sent to all applications. But however, this was changed long ago. And the class that is referenced for step 3, the Firebase Instance ID service, is no longer a part of the library. Instead, the class mentioned in section 4, handling messages, the Firebase messaging service, this is the single service that now exists. And both use cases, the getting your registration token and handling messages, are now, all the functionality has been implemented and is supported in this single class. So we're going to follow all the instructions in step 3, except the class that we're supposed to extend. We are instead going to inherit from the second class mentioned in step 4. So you just got to remember that detail. It's weird, it's peculiar, but that's where we are. So I'm going to create a new service. And here I have the option of creating a service via the methods that we get here. That is right-clicking on my project, going to new, going to service, and selecting service. I never want an intent service. I just want a regular service. I can do that, and this is convenient because it will put an entry in the manifest for me. Remember, a service is a top-level component, so it has an entry in the manifest. However, it's going to come with a lot of superfluous code that we don't need, so you'll just end up deleting that code. Alternatively, you could just create a regular class and then explicitly specify that you are extending the Firebase messaging service. However, if you do that, you'll need to remember to go to the manifest and add the entry yourself. So for simplicity, I'm just going to do it I'm going to use the first method. So I'm going to go to new service and create a new service. Here I can give my service a name, so I can call this my FCM service. I am not able to specify which class this extends. So this is something I'm going to have to do because I'm not just creating a regular class. So the Android Studio doesn't give me the ability to specify a base class. I will leave enabled and exported. It's perfectly fine to have those. And then I'll hit finish. And once I do that, I get a class called my FCM service, and it extends the service class. So the first thing we need to do, well, the first thing I'm going to do is I'm going to change this service to instead of extending the regular service class, I want to extend Firebase messaging service. And once I do that, I can no longer have an override of the onBind function. This is going to be important later. The Firebase messaging service has a final, or it has finalized onBind, which means it cannot be overridden, it cannot be changed. That means we can't directly bind to the service, not via the ways that we would initially do it with where we create our own binder and define our own interface. We're not going to have that ability. So we're going to go ahead and delete that. And now we can start to override the necessary functions. So per the rest of the instructions in 3, we're told that there is a function called onNewToken. Last reminder, this is saying that this function exists in the class Firebase Instance ID Service. That is not the class we're using here. That is not the class within which this function exists. Instead, a similarly named function is defined in our Firebase messaging service. Here we can see onNewToken, where a token is passed into us that's of type string. And our job is to take that token and save it or send it to the application server. Now, when is this function invoked? This function gets invoked whenever our application receives a new token. That is, every time our application, the first time our application runs, this function will be invoked. But only that first time. If we then run our application again, this function will not be invoked because simply running your application does not actually provide your application with a new token. So our goal is the goal of this function is simply for you to be notified that a new token has been made available and to provide it to you. But if you miss it the first time, like if I had just run this program before putting this log message in, it wouldn't be of much use. We would have not seen the log. The second, if I then put the log in and then ran it a second time, I would not have seen anything that showed me this message. So I'm putting this log in. And now, whenever a new token is made available to my app, this function will run. So I just want to run it once so we can basically see what's supposed to happen. But even right now, it's not ready because for this service that I've created to actually be the recipient of the intent that is providing the token, I need to add an intent filter to my application manifest. So here it is in the documentation. I'm adding an intent filter for the action com.google.firebase.instance ID event. So I'm just going to take this entire block, copy it, go to my manifest, and add it to the service definition. So inside the service classes declaration, I add the intent filter as a child. And at this point, I can now run the application and the log will show me my token. So assuming we didn't miss anything, so I'm going to run this and I'm going to then look for the tag token. So we'll go switch back to the log there. And somewhere in here, I'm looking for token. I see a lot of red. Hopefully that's not us. And I should have used a more specific search string because this is a lot. And that was not useful. So I'm scanning, I'm looking for my token. Let's type it one more time, make sure it's not and I'm open to something crashing, but I still expect to find it in here. All right, so I'm getting a message, bad authentication. I'm not doing a direct invocation of get token, but I imagine that's what's taking place inside the library. And, you know, from time to time, these things get updated and something can change. So we want to check to see what might have changed in the SDK causing my attempt to get my token to fail. So let's just look into this quickly. Okay, well, I just did a quick review and I'll be honest, I don't see why I was getting that get token error. And I can run back through the whole thing just to re-verify it, but because the problem is you can only get a first run once. The second time I run it, I don't get the same issue because the onNew token function doesn't get invoked a second time. Because there is no new token, a token was in fact generated. It just wasn't delivered to me properly, I don't think, or unless I missed something. So the issue at hand, though, is that the token should have arrived here. And I'm going to show you two things. I'm going to show you how we really get the token. Even if after a new token has arrived, regardless, I can always get the most current tokens. I'm going to show you that in a moment. But before that, I just kind of want to show you what the general flow is, what you're supposed to do when you get a new token. So the documentation will tell you briefly that you need to send the token to your application server. And I just mentioned that a few minutes ago. But how do you go about doing that? Well, it's a relatively straightforward series of steps that you should be able to get away with in the simplest cases. So what you really want to do is this. You want to first store some sort of flag. You can think of a flag as just being a Boolean value. That Boolean value can be in your shared preferences. Just something that's true or false that will persist across application startups. So you're going to store a true or false somewhere. The flow generally goes like this. When your application receives a new token, reset flag, or, for me, that basically means set flag to false. What is this flag? This flag is going to indicate whether or not my token is stored in an application server. I'm going to send it to an application server and I want to make sure that the server gets it. So the first thing I'm going to do before I try to send it to the server is reset the flag, basically saying the server, the application server, definitely does not have this flag. So again, we're expecting the application server to exist. I'm going to send my token there so that it can use the token to send a message to me. So I'm going to reset the flag locally. I have none. Then I'm going to, in some general way, attempt to send token to server. If successful, then change flag to true. Otherwise, well, open question. The otherwise really just comes down to a knowledge that you need to somehow try again. Maybe this is a message to the user, although it may not make the most useful. It may not make sense to tell the user, "Hey, we could not register your Firebase token with the application server." That's not a user-friendly message. But you want to say something like, "Sorry, could not contact server. Try again later." Do you want them to do something to say to try to reconnect? And the idea is that the failure to register the token is going to in some way limit the capabilities of the application. So you want to try again. So I would do this in every in the unnew token function, but not only here. And this is the key. This function is only triggered in the whenever a new token is received. So only when Google has said your application is going to get a new token. You will also probably need to have some version of this in another component in your application, maybe the main activity, or just some component that gets executed when your application starts, pretty much every time your application starts. You want to verify that before you do anything else. So maybe I put this in a helper function somewhere instead of having it in multiple places. I would basically execute the same function every time my application starts, every time this main activity starts. Simply put, if my attempt to check this, if this flag is, well, it's not the reset part, I'm so sorry. This would just be if flag is, I shouldn't have deleted the whole thing. It should just be if flag is false. In other words, if the server doesn't have, if the server doesn't have the token, so this is really the token flag. If token flag is false, then attempt to send it to the server. If success, change it to true so that the next time this becomes false. If the token flag is, well, then the whole thing is going to be true. So basically we want this to be skipped if we had previously registered with the server. It doesn't hurt to keep sending it, but the point is that you only need to send it once until it changes again. So second question, follow-up question is, how do we then verify that or how do we get the token? So in the FCM service, the token is given to us as an argument here. But any other place that you'd like to get the token, you can actually just get it yourself. So in this block, if I wanted to send the token to the service, I'd want to first get the token. And I can get the token by, I want to show you again, the documentation. It mentions how you can get the token. It's wrong. It's wrong in numerous places. So this mentions another class, Firebase instance ID.get token. This class no longer exists. I do not know how it was possible, how it is possible for this documentation to just be so flawed in terms of its API. I don't know how it can be so outdated, but here we are. Hopefully by the time you're watching this documentation is not as outdated. So again, just pay attention to what it says. Maybe yours is correct, but mine absolutely is not. So the proper steps are to access a class called Firebase Messaging. Firebase Messaging. Then you're going to call get instance on that class. That's going to give you an access to this utility class that does a whole lot of Firebase related functions, or Firebase messaging related functions, FCM. And one of the things that I can do is I can access my token. Actually, so we just saw a function here, delete token, if you wanted to actually do that. So we have here token. And now this is not a string, however, this is a task. And it's a task upon which we can attach different listeners. So a task is something that gets executed. You can think of it as being executed in the background because it's an asynchronous call. And on that asynchronous call, we can add different listeners that can function based on whether we successfully performed an action or it was unsuccessful or if it was canceled. So to know if something was successful, we'll add an unsuccess listener by calling add unsuccess listener. So we're calling this on the token object, which is a task. So we can attach listeners to tasks. And then the add unsuccess listener takes an unsuccess listener. But because we're working in Kotlin, I can just add a lambda. That lambda takes the place of the unsuccess listener's callback function. And it's simple in that you can see it has one argument, a string. That string is the token. So if I wanted to see what the token was, I can now just do a log of token it. And this will show me what my token is. So this is just a token. So I could actually move this logic into here. Take this logic and move it inside the listener, the callback, so that it gets, because this will get invoked asynchronously. So I get the token, then do the check and see what everything else that I need to do. Or you could wrap this part, put the if statement over here. But ultimately, to get the token, that only happens inside the asynchronous piece. So you need to put your logic that uses the token inside that section. The logic that accesses the token, not necessarily the logic that checks the flag. The flag is just something true or false that you are setting or checking. Again, the easiest way to do that is a shared preferences, but it's up to you. So when we run this code, again, despite the problem I was having earlier where I didn't see the code, it's possible that I missed it there. But here, if I now switch over to the log and I type token, okay, so I already typed token. That's good. Here is my token at the bottom of the screen. It's this super long string. I have my, you're not seeing the key because I have my, the tag, because I have it in compact mode. If I switch to standard mode, here you can see activity token, which is the thing I typed here. And here it is. So it's this long string. So this is the string that needs to be sent to my server, to the application server. Once an application server has this string, it can now send a message to my application, and my application can thereafter send data to the specific application instance that has this token. So in this case, it's this app running on my emulator. I can now send messages to this app using this token. Somebody else who installs the application will get a different token that they will also send to my server that I will also use to send information to them. So again, I'm not giving you a specific code for this piece. It's just an algorithm, and the version here, same thing. You notice we're only doing the reset in the on new token part because this is where a new token is received. Here, we can do it when, here we don't need to reset anything. We just need to check, do we have a token that we have not yet sent to the server? If so, try to send the token to the server. And if we have, good, change the flag to true so that it's not, we don't do that anymore. And then otherwise, error, meaning we're going to make sure that we have to have logic where we keep trying to send it. Bottom line. All right, so the idea is now we have this token, this entire string, and I'm gonna put this in my clipboard for now because I'm gonna use it shortly to demonstrate message sending. So we have the ability to get messages sent to us, but right now we don't really have the ability to process them because we're missing two pieces of information. So I'm just going to put this token here. Come back for it later. So we need to do two additional things. So we're going to switch back to the FCM service, and we're going to go back to the guide to see what is missing. And what is missing is section 4 of the guide, which thankfully is a little more accurate. This piece, for the most part, works. So there is another use case, which is handling messages. And this doesn't matter. It doesn't matter here if messages are sent to you specifically or sent to you more broadly. If you want to process messages, you have to implement this bit. So it basically boils down to this. We need a function called on. Oh, wait, actually, I think it actually was changed. It's just called on message received. Oh, well, so I'm not sure why it wasn't coming up. I don't know. Anyway, so here it is. So it's on message received. I don't need to call the superclasses version, as I didn't hear. So on message received is going to be invoked every time a message comes into us in our application, if it meets certain criteria. So there are different things that happen depending on the type of message and whether your application is in the foreground or not. That will determine if you are the one that receives the message. There are two types of messages: notification messages and data messages. And again, if you're in the foreground, you can handle them no matter what. If you're in the background, data messages get handed to you. Notification messages can just be displayed as notifications without you having to write any code. So on message receive, we get this message object. And then our goal is to process that message object to do whatever it is we need to do. So processing that message object can be, well, first let's dive into the message object to see what it includes, some of the stuff. So here we can see that I have an ID. I have a to, who it was to. If I have the message, you might just assume, well, it was to me. But the to can include different things. For example, if this was a topic message, the to will tell you the topic. So that might impact how you process or display this message to the user. Message type, where it's the data that might be found there. The notification information, if it was a notification object, and sender time. So here you can see there are a few functions we can do. But ultimately, if we want to just get the message, usually we extract a data element. And the data element is going to be, as detailed here, it is a map with a string as the key and a string as the data. So we have a string as a key, string as the data. So that means when data is being sent to you, the sender needs to put it in a format that you can now extract. So you can now specify the correct key to get the information that you would like. So in this case, I would call get potentially, or simply using square brackets, I can now specify the key. And I'll get a string back. So the key might be something like data, if that's, that's what we were doing. And then I could see what that message is. Assuming the key is data, I can now see what that message is. Message received. And we have here, let's do it this way. We don't want our application to crash. There doesn't have to be a data element. So if there is data, then we'll do this. All right, so this is what we'll execute if the data is received, but only if the key is data. If this is not data, then nothing will happen. So this is processing the message. But before we can even process messages, we need to add yet another intent filter to our manifest for our service. So here I have another, again, this is in 4. I'm going to copy this intent filter, which is for the com.google.firebase.messaging event action. So I'll take that, copy it, and I'll go back to my manifest, and I will add it as a second intent filter. So it's a sibling of the first filter. Both of them are children of the service declaration, of the service tag. So now I have both of these. If I now do a fresh install, gotta install, this updated application now has the ability to receive messages. So the question is, okay, now how do I send messages? So we're going to put aside the Firebase console for now, which is not you would not necessarily integrate the Firebase console into the flow of your application. The Firebase console is used for sending things like, as I mentioned, campaigns and analytics stuff, tests. But if you are just integrating FCM into the flow of your application, like it's a chat application or just different, you have continuous messaging, then you really need an application server that is leveraging the FCM, the various FCM APIs. Now, without getting into too much detail about how those systems work, what we ultimately want to do is we're going to access and use an application server. So here I have one, and here I have a little script, a little program. The details of it are not that important, quite frankly. Ultimately, it's just a program written to connect to an API endpoint that Google provides. Here it is. And it sends the message as a post. And here we see how this specific script was written. And again, you can find different components to do this in different programming languages. This one happens to be PHP. And this is an old script that I just retrofitted and changed some parts to get it to work. And what this specific script does is that it sends information to an application using, well, here I can see that the data is being sent. Message is whatever is in message will be the message sent. But the key here is payload. So in my code, I had written data, but payload is the term that I used in my script. So I could change one or the other, but I'll just come back to my program and I'll change this data to payload. So that's the key that I'm using. So this key, again, if you're designing the API, the application server, and you are designing the client, then you'll know what data you're using. Or if you are being given an API or information about an API, then you'd probably be told what the key is. Or you could just, dump the raw data and examine it. It's not encrypted or anything, so you can always just look to see what the data is. So it's payload, and then I'll pass in messages. So that's how this one works. Now, again, this is just a PHP script that goes through a bunch of different stuff. Now, in order for this script to send information to a FCM client, it needs to utilize an API key. And here you can see I have an API key. In fact, I've gone through a few. So getting an API key is important because it allows the server to send a message to Google. Google can verify that this sender is authorized, and thereafter it will accept the message and send it or allow it to be sent to the client. So what we're going to need to do is get our own API key so that my server can send a message. If you're not building a server, this part is not important to you, but I'm just going to take you through the entire process so you can see how it works. All right, so let's go to the Firebase console. And what I'm going to do is I'm going to select the project that I was using before. And then my goal is to find the API key and take that key and bring it to my application so that I can send messages. So what we're going to do here is we're going to hop over to Project Overview. We're going to hit the settings icon. And we're going to select users and permissions. And once we do that, we'll be here where we can see the owner of the project and everything else. But I'm not really interested in this. What I need to make sure that I do is hop over to cloud messaging, this tab. And here I'll see different keys. And I can either use one of these keys that I had previously generated, or I can just generate a new one. So here I'm going to hit add server key, and a new one will be generated for me, which I can then simply grab and hop back to my project, my API, my application server, and then I can paste that new key. So I now insert the key. And now that the key is placed inside my script, it has the ability to send information to the specific client. So now that I'm here, I'm going to start to send messages directly to my device. To do that, I'm going to need the specific key. So I'm doing all of this manually. In reality, for a real app, all of this would be automated. All of this would be done by my actual application server. I'd have this key in a database, and all of this would be automated when specific APIs get called. For now, I'm just kind of doing all of this by hand. So here I have a file, and I'll take a quick look at that file. Where I will be able to provide a token for a user, a specific device. Again, ordinarily this will be in a database, a message that I'd like to send, and then using the FCM object that I just showed you before, we will send a message to the specific device, and I can access that page. So this is a little test that I'm able to do. So what I'll do is I'll add I think the first box was the message. So this is not the best form I've ever written. I think this is the message. So hello from the internet. So this is just a little web form. And then here's the token. And if I've done this right, then what I should see is in my logcat, I should see the message arrive. Well, right now I have this token filter, so I'll remove that. And right, so let's try that again. So here we can see, okay, well, I don't need to check here because I can see that my message is failing. So I have multicast ID. I have an ID here, success 0, failure 1. I don't want that. I want failure 0. And then it tells me invalid registration. So it doesn't like something about what I've done in my API. So I'm just going to look into that real quick. Give me 1 second. Okay, so I just looked into it, and it turns out there's actually nothing wrong with my code. I just need to make sure that I have labels for my form. So this is why user experience and user interface design are important. In this scenario, the token is first and the message is second. So it was literally using the message as the token, and therefore it was basically complaining, I don't know what you're talking about. So now we can try sending again. Here we now see success 1, failure 0, and somewhere in here we hope to have seen a message. We'll send one more. Hello again. And we hit send. And let's make a look at our logic, because we should be getting something. So in our service, we were searching for a message received. Let's see if that's in there somewhere. Invalid request payload. So we're getting some interesting messages here. All right, this is how it happens when you do it live. So let's try one more. We'll clear the log to make sure that it's all working the way we would like. And now we'll send a new message. As far as FCM is concerned, this success is telling me that it's working, and we get a message ID and everything. So this message is being sent to this application. We're just not getting anything of value in our handling of the message. So make sure that I'm not skipping a step. So message, data, payload. Okay, so I've ran some tests, and just like before, literally the only thing I did was that I reinstalled the app a couple of times and it now works. I don't know what to take from that. So what I'm doing here is, for the most part, boilerplate. It's a little, it's a lot, but it is boilerplate. And I guess we're just kind of seeing how these things, when you start to integrate different services, different libraries, different components, it doesn't always work in the most straightforward way. I think perhaps one of the biggest variables might very well be my emulator and my network. That's just causing issues, but it does work. So we can now test it again. I haven't promised you no tomfoolery happened. Nothing was changed in the background. So I can now say, here is my message that I'm typing at ... whatever time this is. And I hit send. And here we get, here's the message that I'm typing at whatever time this is. So the messages are coming in as we type them, even though it's coming in from the internet. The information is being sent to my web server. My web server is sending it to Google's FCM server, and then the FCM server is sending it to my specific device instance. Now, I'm processing this information inside my FCM service. Now, this is a service, right? And we've worked with services in the past, and we know that some of the ways that we can get messages from a service involves binding to the service. That's the most straightforward way. And then essentially handing the service a handler, and the service using the handler to communicate with the client, in this case, an activity or another service. Or we can do a broadcast where we have the service basically send a message, send a broadcast that anyone can listen to. Those are not all possible when it comes to dealing with a service, FCM service. Broadcasting, yes, we can, in fact, we can put this message inside an intent, and we could send a broadcast that the activity can listen for, and then we can lock down that broadcast so that no component outside of our application can intercept it, whether that is with permissions or making sure that the broadcast doesn't leave our application, things like that. Another way to do this, and I'm just going to give a very high level sketch here rather than necessarily doing a full implementation, is that we can create an intermediary. That is, right now our service and our activities don't see each other. But because both of these components are context objects, they both see another component. They both see a component called the application context. The application context is this, I'm going to use the non-technical term, invisible component that is always in our application, even though we don't see it. It is literally this item. This application class, this application declaration is implemented by a component that is present in our application. We usually don't have to be concerned with it, but interestingly enough, it is something that we can tap into. And because both components can see it, they can use it as a way to transfer messages between each other. So in the case where the activity cannot bind to the service, and again, you'll recall I mentioned that we cannot bind to the service because the service does not have an open onBind function that we can override. The binding is used by some external piece of the application. We need to find another way. So what we could do here is we could create a new class. We'll call this class my application. And what this class will do is that it will extend application context. So it will be an application. Now, by saying that this is an application, what I'm now going to do is tell the manifest that for this application component, it should use my application that I just created. In the same way we specify that a service is implemented by a certain class or an activity is implemented by a certain class, we're now saying the application is implemented by a certain class. This class that I've just defined. Now, what we can do here, it becomes a little interesting. Basically, what we can have is sort of an interface. Well, not sort of an interface, it'll be an interface. Recall that the activity doesn't know about the service, not directly anyway. The service does not know about the activity, and we don't want them to know about each other. That will increase coupling. However, since they all already know about the application context that's built into the framework, what we can do is sort of allow them to access data that is defined there. So I could define an interface in my application context. This application, this can be message interface. And the idea of the message interface is that I can use it for different things. So the message interface can just be a class, a single function, message received. And we have the message as a string. That's it. But now I'm going to do a few things. First, I am going to implement in the activity the interface I just defined. So this is going to be a message interface. And it means I need to override the function here. I'm no longer using any of this. So the goal of message received is just to be told when a message comes in. What I want is for the FCM service then to send a message to the activity using this function. But it's not going to know the activity directly. It's just going to know that there is an object of this type. Now, how is it going to get an object of this type? We're going to go to the application, and we're going to specify that this application has one piece of data. It will have I could do a late init, or I could do a nullable. Let's do a nullable. Message receiver. The message receiver will be of type message interface, and it will be nullable, and it will start out as null. And now we're going to do a couple of things. So this is some data that it can, this is basically a reference to a message interface object. And here's what we're going to do. We're going to have the activity in its onCreate. in addition to whatever else it might be doing, we're going to have it register itself with the application context. It can access the application with a call to application. That's literally a reference to the application class. But this is not just any application class. If we were to look at the properties that it defines, we see a bunch of cool, interesting things relating to lifecycle and management of memory and all of that. But this is no longer just a specific application. It's our application that is defined by our my application class. So I'm going to cast this as my application. And now that I've done that, it has a reference to a message receiver property. And I'm going to say that I am that property. I am that object. So the activity is registering itself as a receiver of messages. The only receiver of messages. Clearly, I would need to go back and do a more complex system if there were multiple components that could receive messages. And then I'm in the undestroy of this activity, because anything you do, you need to undo. I'm going to remove myself just to make sure that the service doesn't try to do something if the activity is not present. So as long as this activity is present, as long as it's created, it will be a receiver. I could put this in the unresume if I only wanted to receive messages while I'm in the foreground. I could do a lot of stuff. But this is the agreed, what I've decided. As long as I'm in memory, as long as I've created, and then when I'm destroyed, I'll remove the reference. So now what do I do? What's the next step? So the next step is now to go to the My FCM service. And the My FCM service can do pretty much the same thing that the activity can do, because this ability to access the application context is a feature of all context objects. So I can do the same thing I was doing here. I'll take the application and I will cast it as my application. So this is coupling that we're having here, but at least it's coupling to a parent object. So I'm less concerned than it knowing its siblings. It's similar to when we're working with fragments and we say, well, a fragment knows it's attached to a parent as long as we can use some general reference to the parent. Yeah, this one is tying it down a little more, but it's our compromise because we don't have a generalized messaging bus in Android. We just have to find different ways to pass messages depending on which components are doing the communicating. So I'm now basically accessing the application. I'm saying it is this thing. And then I can now check for a receiver and basically specify that if there is a receiver, I want to execute this code. And what's the code? I want to pass message received, and it will be this at run. Well, we're in two runs here, so that's no good. So let's do let, and then this will be it. Well, message receiver. If there's a message receiver, so it'll be it dot message received. My mistake. And then I pass the message, which is this. Here we go. So it is the reference to the message receiver, which is a type message interface. So on it, I can call the message received and then pass in the string that was received. That then, as long as this activity is active, will receive the message here, and we can do whatever we want with it. So our activity has a text view. I'll give this text view an ID. I'll set it up in my activity. Making sure it's a property this time. In my onCreate, text view equals find view by ID. You'll do this a little differently if you're using compose. And then finally here, I can now say text view dot text is equal to message. This a little larger. And now, if we did everything right, and we did a lot without testing, so it's possible we didn't do something right, what I should now have is whenever I send a message, it should show up here. So, hello. Or, you know, it crashes. That's good too. Let's see. So our logcat says we're misbehaving, and that's expected. We did a lot. Only the original thread created a hierarchy can touch its views. Fair enough. Well, we got the message in. So now we just need to make sure. So we're coming from the application context. We're running a background service. So it doesn't like that I'm doing this. So we will try something else. All right, so perhaps the quick and dirty way would just be to, I'll just post this message. Basically, what I'm gonna do is just take this message off of the main thread. Or sorry, I'm gonna post it to the main thread. So this is a little shortcut, a little workaround for dealing with handlers and all of that. Basically, what we can do is post a runnable, which I can pass in as a lambda. And that in that runnable, I can just basically tell it what I was telling this thing, which is tell the text view to take this message as its text property. Not the cleanest work ever, but if we just want to see something running, and this video has been going for a while, let's just get this working. So now we can see that from here we're running. We can now pull this up, bring this over. And now if we say hello, there we see it. Nice to meet you. Finally got it working. So there you have it. Quite a bit of information kind of stuffed into this video. We started out by integrating the FCM backend with our application. We did an integration. When that integration happened, basically our application connected with the Google Firebase services servers, and it downloaded a file. It registered the project and then downloaded this Google services file. Inside, it has all of the information that is necessary to authenticate itself and specify which components it's using. So that's what's done when you connect to Firebase. After that, we added the Firebase messaging components, which then added libraries. Those libraries would have updated our Gradle files. So if I hop into my Gradle file, I'll see that I have somewhere in here Firebase messaging. Here it is. And then once I had those, I basically implemented the receipt of a token, what to do when I get a new token. It broke, but I think maybe the code might have been somewhere there and I just didn't see it. But either way, you saw that we still got a code because I could fetch the code separately. And I fetched the code here using this bit of logic. And then whereas I just grabbed it with the log, I just printed it to the screen, you would of course take this code and do something else with it. You would send it to the web service or save it locally so you can use it later. You don't have to save it because you can always ask for it again. This is quick, probably the most straightforward way. The only thing I was saving was a flag to make sure that I never sent the token to the web server, to the application server if it was already sent. Keep in mind that when I do execute this logic, so if I hop back here, when I do this, success basically means the server is going to tell me that, yeah, I got the token you sent to me. So that means I'm sending back a 200 code or some sort of string or JSON object telling you that, yes, I was successful. So then you verify that. And that means, okay, unless and until I get a new token, the application server has a way to communicate with me. Then we implemented the way to process messages. And as you can see in both of these instances, sometimes it just didn't work the first time. And it's not that there was something wrong. I just installed it a few more times and it would work. And again, sending a broadcast for this message is sufficient to get it to other components, but I just kind of introduced this idea of the application context as a separate topic. Just a way to establish a communication channel between a service and some other component, such as an activity. And ensure that when you are adding the FCM components, you add the intent filters for the service that implements them. And finally, do not forget that the documentation in the assistant is wrong. It has the gist. It just has the wrong API. How that happened, no one knows. All right, so that is FCM. It's weird to say FCM messaging since the M in FCM stands for messaging, but that is Firebase cloud messaging in a nutshell.